Hi, I'm Shyamala, working as Assistant Professor of Mathematics in Humanities and Sciences Department in Nalla Narasimha Reddy Education Society's group of institutions. In this video, I'm going to discuss about the problem on finding eigenvalues and eigenvector in the case of repeated eigenvalues. So the problem is find the eigenvalues and the corresponding eigenvectors of the matrix A. To find the eigenvalues, first we should consider the characteristic equation determinant of A minus lambda I equal to 0. So in the last video we discussed how to write the A minus lambda I matrix and its determinant. So the changes will be only in the diagonal place, remaining all the elements remain the same. So the changes also minus 2 minus lambda, 1 minus lambda, 0 minus lambda. Now we will write the determinant. First take the minus 2 minus lambda into cross multiplication of these two elements. 1 minus lambda into minus lambda minus 2 into minus 6 gives us plus 12. Minus 2 into minus lambda minus 2 lambda minus 1 into minus 6 is plus 6. So minus 6. Minus 3 into 2 into minus 2 minus 4 plus or minus, first we will write minus into minus 1 into 1 minus lambda gives us plus 1 into 1 minus lambda. That is what we have written. Now in the next step, minus 2 minus lambda into 1 into minus lambda minus lambda into minus lambda plus lambda square minus 12. Then minus 2 into minus 2 plus 4 lambda, then plus 12. Then minus 3 we write as it is, then minus 4 plus 1 is minus 3, and then minus lambda equal to 0. Now the second step, now we will multiply these two factors. Minus 2 into minus lambda is plus 2 lambda, then minus 2 lambda square plus 24, then plus lambda square minus lambda cube, then plus 12 lambda. Then these two elements remain the same. Then plus 9 plus 3 lambda equal to 0. Now we will write the order wise. First lambda cube terms I write first, minus lambda cube, then minus 2 lambda square, and then 21 lambda plus 45 equal to 0. 12 plus 9 plus 24 gives us 45. Lambda terms 2 lambda, 12 lambda, 14 lambda, 18 lambda, and then plus 3, 21 lambda. So then what we do is we multiply this with the minus 1, then we will get lambda cube, and then plus 2 lambda square plus becomes minus 21 lambda plus 45 becomes as minus 45 equal to 0. So now by using synthetic division or by using calculators we can find the roots of this characteristic equation. The roots are 5 minus 3 minus 3. So these are the eigenvalues. So in this case 5 and minus 3 minus 3. Minus 3 is repeated twice and 5 is another eigenvalue. Now let us find the eigenvectors for these eigenvalues. So first let us find eigenvector corresponding to lambda equal to minus 3. For lambda, first for the finding the eigenvector we take the definition a minus lambda I into x equal to 0. A minus lambda I we have written already, that matrix into x means x, y, z, 3 unknowns equal to 0. Then in place of lambda we substitute minus 3. Then we get minus 2 plus 3 becomes as 1, and then 1 plus 3 4, and then minus 3 becomes as plus 3 here. Now we perform the row operations on each row and make these two elements, these two we will make 0, and this y minus 1 also we make 0 by performing the row operations on R2 and R3 by using R1. So on R2 we perform R2 minus 2R1, and on R3 we perform R3 plus R1, and then those two elements will become 0. Then 1 2 minus 3 remains as it is, and then this row becomes as 2 minus 2 0, 4 minus 4 0, minus 6 plus 6 becomes as 0. So the second row becomes 0. Third row, if we add these two, 1 minus 1 0, 2 minus 2 0, minus 3 plus 3 0. So we have only one row now. Now if we write it into equation, we get 1 into x plus 2 into y 2y minus 3 into z minus 3z equal to 0. Now we have only one equation but three unknowns we have to find. So to find one equation and three unknowns if we have, then we have to assign arbitrary values to any two variables. So we can assign to yz, or we can assign to xy, or we can assign to xz. To any two variables we will assign the arbitrary values. That means we will take this time as k1 and k2 two arbitrary values, and then we assign them here to y and z. So let us take y as k1 and z as k2 and substitute back in that equation. Then we get x value as x value actually minus 2y plus 3z. So in place of y write k1, in place of z write k2. So this is the x value and those are y and z values. Now the eigenvector x equal to xyz. In place of x write this one. Y is k1, z is k2. Now let us write it as two vectors. One is the k1 components, another one is k2 components. K1 components, if we write here, k1 component here is minus 2 and k1 component here is 1, and there is no k1, so this component will become 0. Plus k2 components if we write, then here it is 3 and there is no k2, that is why it is 0. Then k2 into 1 we have, so we have got two vectors, linear combination of two vectors we have now. So we will take this vector as one eigenvector and this as another eigenvector. So we got two eigenvectors. So whenever a eigenvalue is repeated twice, then we will get usually two eigenvectors, but sometimes we may get only one eigenvector also. There is no rule that always we get two eigenvectors, but usually this will be the way of getting the eigenvectors whenever it is repeated. Now eigenvector corresponding to lambda equal to 5. We again consider a minus lambda I into x equal to 0, and then write down that a minus lambda I into x equal to 0. In place of lambda, let us substitute 5. Then minus 2 minus 5 minus 7, 1 minus 5 minus 4 minus 5. Minus lambda is minus 5. So this is the equation. Now again we should perform the row operations on R2 and R3, and then we have to make them 0. First of all, if we go back to the previous page once again, see we have minus 1 here in the last row. So if we take this into first row, then our operations will become easy. That is why first we will interchange R1 and R3. So from the previous matrix to this matrix, the change is only the interchanging of R1 and R3. R2 remains the same. Now on R2 we perform some row operation and make it as 0, and this also we will make 0 by using these two row operations. On R2, R2 plus 2 R1, and R3, R3 minus 7 R1. Then first row write as it is. On the second row, this will become 0 because 2 minus 2 becomes 0. Minus 4 gives you minus 8, minus 6, minus 10, minus 16. Then on R3, minus 7 plus 7, 0. 2 plus 7, 14 will give you 16, and then minus 3 plus 35 gives us 32. Now we perform row operation on R3, and let us make this 16 also as 0. So on R3, R3 plus 2 R2. Now we have to use R2 to make this element as 0. This 16 we should make 0 by using R2 only now. So first row, second row will remain as it is. On third row only we are applying the row operation. R3 plus 2 R2. 16 plus 2 into minus 8. 16 minus 16 0. 32 minus 32 0. So now what we do, the another operation is, let us divide this second row with 8 so that the numbers will be in the very small numbers. Then our work will be easy. So 2 divided by 8, then we get -1 and -2. Now we will write this into equations and find the x, y, z values. This is the first equation. This is the second equation. From the second equation, y minus 2z equal to 0. That means y equal to minus 2z. Here we have two equations. We have to find three unknowns. So we will assign any of the variables to some arbitrary value. So let us assign to z as some k. Then y becomes as minus 2k. So we got y and z. Substitute these two in first equation, then we will get x value. So substituting this into x value, then we get x equal to minus 2y minus 5z. So in place of y write minus 2k, in place of z write k. Then we have x value as minus k. So write all these into the vector xyz, minus k minus 2k k. K if we take out, then we get minus 1 minus 2 1. So this is the third eigenvector. Of course, whenever if we want to use these eigenvectors, we will take k as 1. So these are the eigenvector x1, x2, x3 are the eigenvectors. So whenever a eigenvalue is repeated twice, then we will get usually this kind of procedure. We will have only one equation and we should find out the three unknowns. So we will assign two variables to two arbitrary values and then we will get two eigenvectors usually. In general, we will get like this, but sometimes we may get only one eigenvector also. So thank you.